Okay, go ahead and get started. So I suspect people are starting to get into the meat of the problem set in terms of problems 3 and 4. Are there any questions so far that people want to ask? Big picture of what the goal is, or any uncertainty about what I want? Okay. As I mentioned in the announcement last night, I'm going to be gone a bunch this week, so I'm leaving just after class and getting back Thursday afternoon. So I'm not holding my office hour on Wednesday, but Tessa will be having class on Wednesday, and I'll be back for class on Friday, and I'll have an extended office hour on Friday afternoon. Okay, so I'd asked you to, for today, to try and get a sense for the PS command in Unix. And I was thinking I might have people put up their solutions on the board, but I realized as I was thinking through it that there's really not all that many variants on the answer. So that probably wouldn't be as interesting as for other problems where people might have come up with quite different solutions. So I think I'll just ask for a volunteer to say what they came up with, and then we'll see if there are any other variations on what people did. So what did people find? Would someone like to volunteer to tell me what they found out about using PS and trying to get the listing for all the users in the various fields that I had specified?
I used the option O.
Okay, so what does the -O do?
-O and PC, PU.
Okay, so the -O allows you to tailor the fields that you want?
Field, yeah.
Okay.
So I choose.
So you did PS -O.
I can use AO if you want to do this all the.
Okay, so you did. Did you do it like this?
Small A.
Oh, small a. So let's just see what this does. Okay, actually, it's going to be more interesting if I do this on one of the SCF machines, because otherwise there aren't going to be a lot of other users on this machine. Okay, so this is R1 where there's at least one other user running a serious job. Okay, so you said -A?
AO.
Okay.
AO.
Okay, and then what?
PC, PU.
Okay, so this is getting the CPU.
There's a space between O and PCPU.
Okay, it may not matter, but that.
Yeah,
I'm not sure. That's a good question. Okay.
VSC.
VSC?
Yeah.
What's that one?
Next one, user USC.
What is the VSC?
VSC is the memory.
Oh, okay, that's
in
interesting.
terms of the not the percent in memory, but.
Oh, okay, let's do it actually as the percent memory, because I think that's a little more interpretable.
PID.
Okay, process ID.
And COMM.
Okay.
And then I use.
So you can see, it's interesting. It looks like it was able to interpret that as the full command. Does that also work? Oh, that's interesting.
Oh, yeah,
yeah, so you sort of play around and realize that depending on what you put in, it might do some different thing, to have some different behavior than you realize. So it looks like depending on whether we shorten command, it gives a shortened version of the command, and if we type out the full word command, it'll give the full set of command, the full command that was called. So we're getting CPU usage, percent memory, the user, process ID, command, and it should show all, if we look in the man page for PS, it should give us an indication of, this is actually nice because most of the Unix man pages don't really have much in the way of examples, which is kind of a pain at times. But this one actually does give some examples of usage that provide a sort of a quick start into what you might want to do. And it looks like starting to get a sense from some of these examples of what the different options are in terms of specifying the fields that you might be interested in. And it should list those a little more systematically somewhere. Yeah, it looks like, obsolete sort keys, okay. So that's for sorting. I thought I was going to try, oh, here we go, okay. Okay, so here are the various possible fields that we could want for information about each of the different jobs. Did anyone have anything any different than what was your name again?
Henry.
Henry. Then Henry came up with?
I use
-EO? Okay, yeah. So I think the -E and the -A are basically just synonyms for each other, but we can see if that gives basically the same thing or not. Okay, that looks essentially identical. Anybody else? Anybody come out with? Oh, it looks like that's interesting. It looks like the -e is giving a more complete listing of all the jobs. I'm not totally sure of exactly what the distinction is, except it looked like with -a we weren't getting all of those system level jobs, which might not be of interest to us. So maybe the -a is a little bit more useful if we don't want all of those jobs. And I don't know if there's a distinction between lowercase a and capital A. No, it looks like that's identical. Any other options that people come up with? Yeah, caution.
You can just use the V flag, then you would have to type in all these. It'll give you everything, but it also gives you these things.
So what does V do?
It's the verbose output.
Okay, so oftentimes in Unix commands, V means verbose, which means give me a lot of information. So if we do that, oh, that didn't work. Huh. So usually something like that will work. Sometimes you can do this. That didn't work either. Yeah, interesting. So it doesn't seem to like the -v in this context. I'm not sure.
So it works on my shell.
Yeah, no, yeah. Sometimes there are differences on different operating systems or whatnot. -e -v. So didn't really like that either. Yeah, somehow the -v doesn't seem to be happy with that in this particular context. Anybody come up with anything else? Yeah.
Sorry, the -v is only in BSD Unix, so it works on Mac.
Oh, okay. Yeah, so there are different variants. Can you give a better description of what BSD is compared to the regular Bash shell?
I think BSD is like a souped-up Unix shell that people in the Berkeley CS department run.
Okay, yeah. So there's some different syntax for. I'm not sure. Does anybody know if BSD is a variant on Bash or a variant on Unix itself? I'm not totally sure I'm a little unsure of my footing here in terms of actually how to describe it. But if you look in the if we do man ps, you can see there's often the case that so it's probably basically a different variant of Unix, because here it's saying there are different kinds of options to PS: the Unix options, which is what we were working with, and then the BSD options, which is, like I was saying, just a different variant of Unix. And often the BSD options don't take a minus, so the syntax will look something like this as opposed to something like that. So just to make this even more confusing. So I've tried to be consistent in what I've done here in class to just use the regular Unix options. Okay, did anybody get the restricting to just R jobs to work? Yeah. Minus capital R? That's probably not going to work, because the minus is just going to be a flag to PS, and it's not going to know about. Okay, minus capital C. So yeah, I was playing around with that as well. I ran into some troubles with that, so I don't know. So what did you do? Minus C and then R? Right, right. So if we do that, oh, that worked. I was playing around with it on my.
It's because there's no -c on your Mac BSD machine. I had seen
Okay. Right. Okay. Yeah. So I think that's right. So if I do it here, oops, PS -CR. Yeah, it says that's an illegal argument, or let's say bash. Yeah. So it doesn't like that. So it's a little frustrating that it's different on. Yeah. So I guess that's because my Mac is running the BSD variant of Unix, and therefore things are somewhat different. But if you're on a regular Linux machine, we can do this -C and then the command. So folks might have thought of the idea of doing the following. So piping together are the different kinds of things that we know how to do, and we could just do a grep. Let me do the -e as well, or the -a. Of course, the difficulty with doing the grep is then it's going to find anything with a capital R in it. And so, for example, it found this vim command that had a capital R in it. So whereas the -c is a more elegant way to do it, because it's actually restricting based on the actual job instead of just grepping for the pattern within the result of running PS. Okay. Any other thoughts on this? Okay, so it's sort of illustrated a few different things in terms of different kinds of flags, the fact that there's this BSD Unix and standard Unix, and sort of unfortunately for us, as we're going back and forth between the Mac and Linux, that there are some variations that actually matter to us. Okay, so let's go back and finish off the bit in the bash unit before we get into the Git stuff. So were there any questions about the for loops? I sort of went over that right at the end of class on Friday. Anything come up as people were looking at this over the weekend, or any remaining lingering questions from last time? Okay. So that will be useful for the problem set. So I did want to also just look at this one other example of some Unix syntax, some bash syntax. So this I just pulled off of somebody or another's website. I think Brian Caffo at Johns Hopkins taught a computing class a few years back that I was borrowing some material from, and I found this, and I thought this was kind of a nice example. So this gives an example of what if-then-else syntax is like in the bash shell. So what I'd like you to do is take a minute and just sort of look over this and try and see if you can pick out some new syntax that we haven't seen before, and see if you can figure out what it means, just sort of from the context and the fact that there are these echo commands in here that give some indication of what the commands above them are actually doing. So see what you can figure out from that, and then we'll talk through it. And feel free to discuss it with your neighbor as you're looking through it. All right, so if there are things that you already knew before this class because you were already doing a lot of stuff with Unix, don't answer. Don't provide an answer here. But what did people notice that was new that they haven't seen before, either seen before just now or seen before the start of this semester? Yeah. Tom. Okay, so did you get a sense for what that might mean, given in this context, given the helpful echo commands in here? Anybody else want to chime in with what they thought about that?
So if the second file already exists, it's true.
Okay, so we don't really know explicitly what the arguments are, but we know this means the second argument, right? So it's saying, so it's basically saying, does that exist? Does that second argument, so whatever the second argument values to and assume it's presumably given this message here, it means it's trying to get a sense of whether the file exists. So it's hoping that you'll pass in a file name as the second argument, and it's saying, does that same thing exist? So if we look down here, what it's going to do is it's going to do R. It's going to take as input the first argument, so that should be a file name, and it's going to take as its output the second argument, so that should be the name of a file to send the output to. And here it's saying, does that, once it evaluates this argument, and then it's going to say, is that the name of a file that actually exists already on the system? And if it does, then it's going to give us a message saying, oh, that already exists. I don't want to overwrite it because I'm not sure whether you actually want to overwrite it. Okay, anything else people will notice here? Yeah.
I guess $pound is
Okay, yeah, so that's a nice catch there. So there's this special variable in the shell that's telling us how many arguments were passed in, because since we're not explicitly defining what the input arguments are, we don't actually know how many the user gives us. So it's nice to do a check here to see how many the user gave us and make sure it corresponds to what we're expecting, and so that we can have so that the code here is consistent with what the user's giving. So it's saying, you know what? If you don't give 2 arguments, then it echoes back and says, this is how you actually use this little function. You give the command, you give the input file, and you give the output file name. Anything else folks noticed in here? Yeah.
There seems to be exclamation mark.
Okay.
I'm guessing it means it's not.
Right, so that's negating the minus e. This is saying if it doesn't exist. So this says if it does exist, this says if it does not exist. And this is a common negation thing in a lot of different languages, and we're gonna see it. Most of you've probably seen it in R already, but that comes up a lot. Another thing that's kind of tricky here is sometimes you need to make sure you get the spacing just right in some of these if statements. I think this may not work if you don't have spaces here and here, and I'm not totally sure about that. So if you're playing around with this, one thing to do is just sort of try different variants of putting spaces in and taking spaces out, because sometimes it's a little bit finicky about that. Oh wait, actually there are two nots here. There's a not there and a not here. You also notice we need to put in quotes the $2, so it actually evaluates what the variable is, and then that gets passed into doing the checking of whether or not that file exists. Let's see too much else here. Anything else? Well, obviously, so there's this whole if this is true or not true, then it evaluates ifs. If it's else, this stands for else if, else as in the alternative to this then here. If this is true, then do this, otherwise do this, and so it sort of marches through this chain of different possible conditions. Anything else people noticed as being interesting?
No. When the function prints out the information that echo information, will $2 be substituted with the second argument name, or it's just $2?
Yeah, so that's a good question actually. And what's your name?
Udia.
Udia?
Yeah, or GD.
Udia? Okay, that's easier. So are you asking in here whether or not this gets evaluated? Yeah, so I think I may have pointed out either somewhere in the notes or maybe in a posting that I think what's going on, what usually tends to happen is if it's in double quotes, then it'll actually evaluate the argument, the variable, and if it's in single quotes, it won't, it'll just pass it through. So it should actually print out whatever you passed in as $2 as the second argument. Yeah, so that's a good thing to know about. Okay, so that illustrates a few different things, that some of which we've seen before and some of which are new as of just this morning. So let's go ahead and move on to the Git material. Okay, so this is section 14, which I added just in the last few days. Actually, so before I do that, any lingering questions about any of the other Unix, any of the other Bash material that we've been going through over the last day or day and a half or so? Okay. Okay, so the idea of version control is at its most basic, we want to try and keep track of what version of things that we're working on, and so that we know when changes were made, and if we want to go back to our work, we know, so what the flow of the different changes we had made. And this is particularly important if you're sharing material with other people, because you send them an email on September 5th, and they're working on stuff, and then you go ahead and you continue making changes, and then you say to them, hey, in line 14 of my code, or in the data set in line 12, this is what I'm finding, and they've already made changes to the code, you've made changes to the code, their line 12 is not the same as your line 12, their data set is not the same as your data set because you've made some additional changes to the data set. So you want to have some idea, some ability to say to the person, hey, the data set that was version 3, make sure we're working in a common context. Then we can talk about what line number and what the details are. So at its most basic, you could think about just sort of numbering the different versions of your code, or if you're working with the data set, numbering the versions of the data set as changes get made to the data set. But more formally, what's come up recently is actually doing this via software and using version control software. And so the nice thing about version control software is it allows you to handle pretty complex workflows where you're not just working with yourself, but working with other people. And so you can, if you go ahead and make some changes and you realize that you don't like the changes you made, you can go back to an earlier version quite easily. You could have multiple versions, so you could be trying something new out while you're keeping sort of the master version clean and not corrupted by the things that you're trying out that you're not sure if they're going to work. And you can also share your work easily with other people. We've already been sort of demonstrating that by me sharing all of the materials for the class with you guys, and that you can just update based on the changes I've made whenever you want to update that material. And I've just been using it in the context, of just being able to get files onto my laptop that mimic the files that are on my SCF home directory, which is where I'm doing most of my work. And then the other nice feature of it is if you do have a repository on multiple machines, that's going to provide you with an automatic backup because you've got copies in multiple places. Okay, so a couple of warnings about this demo. One of them is that it doesn't seem like knitr and these embedded chunks of code, seems like sometimes things don't quite, the output that gets printed to the screen and embedded in the PDF doesn't look quite right. So there might be some things in here that in the PDF that are not quite the same as if you ran it on your own. And the other thing that I will say is I'm not a world expert on Git. This is something I've been learning over the last year and learning more intensively over the last few weeks. And so there may very well be a few of you in the audience who know more about it than I do. So if you're as we're going through this, if you notice things that you can contribute and add to what I'm saying, or if you think I've said something incorrectly, please do chime in and pitch in. Okay, so there are a lot of different version control systems. The one we're going to look at is one that's become really popular recently, which is called Git. And basically the idea is that you're going to have have all of your materials, sort of a working directory of files stored in a repository. And that repository can be mirrored on multiple different machines and mirrored on machines of different users. So there are a few snapshots here of basically this idea that you've got different chunks of material that are called blobs, and they're stored in a tree, so you can think of this as being a directory on your system that has subdirectories, and that's the structure of the information that you want to store. And then there are going to be these things called commits that are basically you telling the system that you've made some changes and you want to store a snapshot of the changes that you've made, such that if you needed to, you can either go back to that snapshot or you can march along and make changes and update your snapshot. So that's sort of the basic idea. So you're going to be sort of working along. You're going to take this snapshot, make this commit, not sure why it goes from C to B to A, but you're going to have this version. You're going to have this snapshot. You're going to make changes, make a new commit. You're going to have then have this next snapshot. You're going to sort of keep marching along. And if you needed to go back to a previous one, you can go back and do that. Okay, so one thing we'll see is that Git basically names these different commits with a hash. And so basically a hash is a way of taking a big long sequence of information that could be of sort of arbitrary length and reducing it down to basically a unique identifier of a fixed length. So we'll see more with hashing in one of the units to come. But just to mention this basic idea that you can take, and this is just some R code that uses this digest package. You can take these, for example, these R objects and use a hashing algorithm. And in this case, we're going to use an R function called digest to create the hash. And then it'll print out this unique identifier, which looks, because of the C's and the F's, it looks like it's in base 16. And then if we add some additional material and run the digest function on that, we're going to get a new hash that is different from the old one. So these are now sort of unique identifiers of the different stuff that we passed into this. Okay, so let's go ahead and switch over to the demo code, and let's just work through a basic demo. So we've already seen examples of just cloning the repository, so I've already sort of done that in front of you a couple times as I've either cloned the repository fresh onto my machine, or once after I've cloned it, if I just want to update things from the remote repository, I've just done a git pull. So if I go to the place where I've been storing the files for this class, I've already done the git clone when I first set things up. Actually, I can just, I could just get rid of this. All right, so I'm just going to remove it, and now I'm going to clone it again. Okay, so now it's creating that directory, copying all the files down from the remote repository, and now if I cd to that directory, it should show me all of the stuff that's in there. And if I had made changes in the interim between the 2 seconds ago and just now, I could do a git pull, and it would download all of the new changes. In this case, it's already up to date because obviously I just cloned it, and so there's nothing new to be, there's nothing that's been changed in here. So that's how we can get the material from an already existing repository. But let's actually work through the process of actually doing this and creating a new repository here that's fresh. So we can, if we do git help, it's going to give us a whole bunch of information about some of the basic git commands. So add, branch, checkout, clone, which we've already seen, pull, which we've already seen. And if you want to get help on a particular one of these commands, we can just type the name of the command. And so this will, for example, give us information about what does it mean, what are the options that we can use when we do one of these pulls to get material from a remote repository. Okay, so let's go ahead and start out and do this fresh. So I'm just going to go, I think I want to use that one. I'm just going to go to /temp and remove the demo that was already sitting in there because I'd run through this once just as a check. And so now I'm going to do git init, and that's going to create a new repository, a fresh one that we can then populate with information and then start to work with. So when I go ahead and do that, it says, okay, it's initializing an empty repository. I can now go to that directory and I can type ls. Doesn't look like there's anything in there, but I forget if I've mentioned this before, but if I do ls-a, that's going to show us all of the hidden files, which are the ones that start with a period. So if I do ls-a, it says, oh, you know what? There's actually something in here that was hidden from view that's a directory called .git. And I could do ls-a within .git for the stuff within .git, and it says, oh, there's a bunch of these different different directories within this .git directory. And that's going to contain all of the information that Git needs to basically do all of the version control and just manage this whole process. Okay, questions so far?
What's the advantage of making a repository public?
Basically, then it's going to make it easy for other people to share, to get copies from you. So I made it public, for example, so that you guys could all get the material for the class. Yeah. At least on GitHub, the particular hosting site, the public ones are free. You can get private ones where I could share it with you, but not with the whole world, for obvious reasons. There was another question over here.
Yeah, for the homework, you said that your Git repository for this class isn't editable by us, right?
Right.
So our progress on it won't show up in the logs. So should we just make a Git demo for the homework?
Yeah, the idea for the problem set is that you would make a local one of these just on your local machine. You wouldn't have a remote version, and you would just work through it on your local machine, and then you'd show me in the problem set in your problem set solution what the log was of the different changes. Yeah. Okay, so let's go ahead and I've basically put this CD in because when I was making the PDF automatically from this documentation embedded in the LaTeX document, I wanted to make sure that it was in the right directory. You don't actually need to do this CD every time in this context of just doing the demo because we're just going to be sitting in the same directory most of the time. Okay, so I just created a file, this file1.txt, by using echo and then redirecting the output into a file. So that creates a silly demonstration file, and I now have that sitting in my working directory on my file system. But it's not yet, I haven't yet told Git that the file exists or that Git should keep track of it. So if I do git status to sort of get a sense of what does Git think about the status of this directory, it says we're on what's called the master branch. We'll see about branches in a few minutes. There's been an initial commit to basically what's the initial status of the repository, and then it says there's some files that are untracked that Git is in some sense aware of, but it's not really part of the working repository. And it gives you a little hint about what you could do if you wanted to react to that, to the comment that it makes. So it says you can use git add to add the file into what's called a staging area, and then we could tell it to commit it and make it part of our working repository and part of the current snapshot. So okay, let me go ahead and follow the suggestion there, and I'll add it to the repository. So it says, so I do git add in the name of the file, and now if I do git status, it says, okay, so we're still on this branch master. It says there are changes that are not yet committed that would need to be committed, but there is a new file that Git is now aware of. So basically, we've sort of put the file in what's called a staging area, but we haven't yet committed it to this snapshot that's going to keep track of a sort of cohesive unit of snapshot of where we are. Okay, so if once we've done the addition, we can now do a commit and say, okay, yeah, really keep track of these changes that we've made. So let's go ahead and do that. Okay, so what does it do? It prints back some stuff. So I said git commit, and the M part of this is basically a message, which is a good idea to have to give you or anybody else who's working in this repository an idea of what were the changes that you made for this particular commit. So my indication was, well, this is just our first commit. I probably should have said something about the fact that I added file1.txt at this point, and that should have been part of my message. I'm forgetting exactly what the -a means, except that in general that's what we want to have in there. So if we do git help commit, let's see what it says about -a. Okay, so this is saying, okay, if you've gone, are likely to have modified or deleted files as you've been working in your working directory and working on your project, and this A says basically any changes that you've made, go ahead and commit those changes to the repository. So that's generally in my workflow, I'll be using the -a, and so whenever I do a git commit, I'll do -a and -m to stage all of my changes, and then to have this have this message associated with the commit. Okay, so it also says, oh, you know what? In this commit, there was one file that was changed and something about inserting material. So I guess that's probably the insertion of that's probably the actual insertion of the file. And so this is the file being changed, and the insertion is referring to the same thing. So now if we do git status, we can say, oh, it's on the master branch, and it says there's nothing to commit. We haven't staged anything into the staging area because we already staged it and committed it, and now everything's sort of in a clean state. And that's what when it says the working directory is clean. And if we do something called git log, it'll give us basically a log of the different commits that we've made, the different snapshots of what the repository looks like. So here's where we see this hash key that basically is sort of the name of the commit, the unique identifier of the commit. And it says, oh, okay, I was the author, this is when I did it, and here's that message that we wrote in that's giving us some textual information about what the changes were associated with this particular commit. Okay, any questions about that? So I could go ahead and change file1.txt. Remember, that was the file that we first added to the repository. So a standard working mode is we would have committed changes to a file. We then go ahead and make some more changes to the file. And in this case, I'm going to mimic that by just echoing some more text and appending it into that original file that I had already changed. And one other thing that you can use is this git diff, which is sort of mimics what the Unix diff command does. So a Unix diff will tell you the difference, what the difference is between two text files, and that can be quite handy at times. I don't think I'd mentioned that before. But if I do git diff here, it's going to say, you know what? Here are the differences in file1.txt, or more generally, the differences in the directory relative to what you had committed before and the changes that you've just made. So it says, you know, you've got file1.txt, you have a new version of file1.txt, and in the new version you've added, this was what was there originally, in the new version you've added this, and that's indicated by this plus sign. So as you work with this, you'll get some sense of what the syntax is of the results of doing this, using this diff command, and you can see what the differences are between the old versions of the files and the new versions of the files. Okay, so now if I've made a change, then I'm going to then generally want to commit it to make sure it gets reflected in the repository. So I'm going to go ahead and do another git commit, and now if I do git status, it should again say that things are clean, that there's nothing left to commit. And if I do git log, it's now going to say that it now actually records that there have been two commits. Here was that first one, and here's the more recent one. This is the one where I made the second change to that file1.txt. Okay, so the information in this log is sort of verbose, and we might want a shorter snapshot version of that. So we can use this set of flags to the git log command, and this is going to give us a shortened version that just gives us a short piece of that hash key that's associated with each of the commits, and then gives us the message that we associate with each of the commits. So this is just a less verbose way of showing where things are. And this is a little bit of a side point, but we can create things called aliases within Git, sort of like the aliases that we talked very briefly about in Unix. So I'm going to create an alias called slog that's going to be able to do all of this without me having to type all that in, so I can just type git slog. And we'll use that as we continue with the demo. Okay, other questions or comments at this point? Okay, so we've seen adding a file to the repository, and we've seen making a change to a file and staging those changes and then committing those changes. We can also either move or remove files. So if we wanted to change the name of file1.txt to file-new-name.txt, we can go ahead and do that. And if we do a git status, it says, oh, there are still things that remain to be committed that hasn't been committed yet because I haven't done git commit. But it does say, hey, what you've done is you've renamed one file to another file. And of course, I can go ahead and do what is now becoming our usual set of operations. I can go ahead and do my git commit, and it says, oh, it's gone ahead and it's renamed the file. And then the short log says, here was our first commit, here was that change to file1.txt, and here was the renaming. So that I've now got a series of three commits in my workflow. Okay, now if I just want to show a demo of removing a file, let's go ahead and add a file that we're then going to go ahead and remove in a moment. So I just went ahead and added a file test.txt. I can see that I've now got two files in my working directory, and if I do git status, it says everything is clean, so those two files, that means those two files are indeed in our commit, so they've been recorded. So now if I want to remove a file, I can go ahead and do git remove. So you'll notice a couple things. If I do git status, it says there's a change that's still remaining to be committed, which is this deletion of my file. It's also interesting that if we do ls and look for test in the current working directory just on the file system, it doesn't actually show the file anymore. So it did go ahead and actually just remove the file from the file system, as well as making this deletion in the index, in the staging area, but it hasn't actually made the commit yet. Yeah. So
do you have to do git commit every time you make change.
Yeah, basically, anytime you want to take a snapshot and basically make a record of the changes you made, you want to do a git
And you
commit.
cannot skip this. I mean, it's not optional then. So keep
No, it's at the heart of what you should be doing in terms of as you're going through and doing your work. Yeah, question.
Does it
And wait, I'm still trying to learn names. So you were Henry, right? And what's your name?
Sarah?
Sarah. Okay.
Does it just commit the very last command that you did, or
No, I could do git add file 1, git add file 2. I could make changes to file 3. I could do git remove file 4, and then do a git commit, and it'll record all of those changes.
how does it know where to go back to, or does it just go back to the last thing commit?
Right, so it's basically working off the commit. So you've made a git commit, that's your current snapshot. You make a whole bunch of changes as you're working through. Now you do a new git commit, and that's a new snapshot that reflects starting with the old commit, making all these changes, and where you are now. Okay, so I've removed this file. It's disappeared from the file system, but it's not actually committed yet. So I do need to do that commit. So I'm going to go ahead and do that. Okay, now if I do git status, it should show that things are clean, that there's nothing else left to commit, and if I do git slog, the short log, it should show all of these various things that we've done so far with the useful messages. Yeah. And what's your name?
Darren.
Darren.
Is there a way to undo what you have done once you commit?
Well, basically, you would then need to make the changes and do another commit to basically undo it. Or you could go back to a previous commit, which I think is git reset, although I actually haven't done that much, so I'm forgetting exactly the syntax for going back to a previous commit. So you basically should be able to go back all the way. It should store all of the changes. The other thing I should mention is this is really primarily devised for working with text files, because when you've got text files, Unix is very easy, is able to handle, or it's not just Unix because there's versions of Git for Mac and for Windows, but Git is able to basically do a very efficient job of handling changes, because you could take some really long file and just make a change in a few different lines, and Git is not going to save the old version of the file and the new version of the file. It's going to save the old version of the file and then just the changes that were made to get to the new version of the file. So if it's working with text files, it can do that pretty efficiently. And if you're just making changes here and there, even if it's a big file, you're not going to be storing zillions of copies of the file. If it's a binary file that's not just a text file, if it's a Word file or it's an executable or something, then it's going to store it's going to store a whole new copy of that file, because it's not able to do that easy updating of text files. I think I got off on that because you asked a somewhat maybe separate question. Did I answer your question or not?
But then what happens if you keep deleting and editing the same line several times?
Are you gonna? Do you mean that you're committing as you go along or not?
Yeah.
Well, yeah.
Edit back, delete it again, and edit back.
Yeah, I mean, maybe it may have a way to be more efficient about it, but what I imagine it'll do is it'll record the change to do the deletion, it'll then record the change to do the addition, then to do the deletion. So there's probably a little bit of inefficiency built in there.
So you shouldn't do much copy paste in this case. Remove copy paste.
Well, I mean, it's fine to do that. It's not. I don't think it's a big deal, and it's unlikely that you're going to be, sort of removing the same big chunk and then adding back in and then removing it. So. Other questions? Yeah. Wait, don't tell me. Huh?
You had it the other day.
Yeah. Jeff?
Yeah. So is there a way to do like space management? Like, say, okay, Git, you can use 10 megabytes of space, or?
I don't actually know. That's a good question. Does anybody know? Yeah, I'm not sure. Okay, so Darren had asked about basically going back once you've already made a commit. The example I have here is, what if you want to undo a change after you've made a git add, but you haven't yet done the commit? So you've put it in the staging area, but you haven't yet committed it. So here's an example of doing that. So I'm going to put some new information in my test.txt, or I'm going to create test.txt. Okay, and now I'm going to add it. Okay, so now I've added it. So I just wanted to get that file in there. So So now suppose that I went ahead and did a git remove. Okay, so git status says this file has been deleted. If I do an ls, remember that we've already seen when we do a git rm that it actually just removes the file from the working directory as well. So now I'm sort of stuck. I'm like, well, I haven't committed it yet. And what if I now decide I actually want the file back? I didn't really mean to remove it. So that involves having to do a little bit more involved processing. So I've just been sort of working through this in the last couple weeks. So this is my understanding of how this works, which is first we're going to do this git reset. And that's basically, and we're going to give it the file that we want to do, what we're trying to retrieve. And basically what that should do is basically go back to the commit. And remember, we did a git rm, so that affected the staging area. We're going from the, actually let me show a picture that I pulled in from a git book just this morning as I was trying to figure out what was a good way to describe all this. So we can sort of think of it this way. So we have our working directory. That's just the directory on the file system. And we have our repository that has all of our commits in it. And if we do a clone or a pull, or we'll see with branches, if we check out a branch, we're basically going to go from the repository and check stuff out and have those changes reflected in the working directory. And when we do git add and git remove, git rm, and make changes, we're basically putting stuff into the staging area. And then when we do a commit, we're taking it from the staging area and putting it into the repository. So the way I think that's a reasonable way to describe this git reset is we're basically going, we did the git remove, so we removed the file from the staging area, and then we're going to do a git reset to basically take the information from the repository and have the staging area mirror what the repository looks like. So that's going to sort of get the file back from the repository into the staging area. And let's see, so I haven't run that yet. Okay, so this, but now if I do an ls, it'll say, okay, I still don't see test.txt in my actual working directory. So then I actually want to go ahead and do a checkout and give it the name of the file, and that's actually going to repopulate my working directory. So now if I do ls, I should see that the file's been actually restored to the working directory. And if I do git status, that should say, okay, I've sort of cleaned everything up. I've gotten it so the repository and the staging area and my working directory all are reflecting the same information. Right, I already did this. Right, I already did that. So we can see that this now has the file that I originally did the git rm on is now back. And there's a little bit more information in the PDF of what if you wanted to do. What if you made a few different changes that you wanted and you hadn't yet committed them and you didn't actually want to make those, you decided you didn't actually want to make those changes? So you can do git reset --hard and then head, and that should basically sort of repeat the process we just did, but for multiple files at a time without having to do the git reset file 1, git checkout file 1, git reset file 2, git checkout file 2, etc. And this thing called head is basically a pointer to what the most recent commit was. So it basically says sort of where am I in this set of chained commits. So that's a little bit about sort of navigating through these various places and this idea of staging information and then actually committing it to the repository. So I think I'm going to talk about branches. Let me just introduce the idea of a branch, and then we'll come back to this on Friday. So the basic idea of a branch is you, or maybe you and some other person, might be working on a project, and you might want to make some experimental changes that you're not sure they're going to work. And so you want to have sort of 2 working versions of your work. So we can make a branch, and basically that's going to, we're going to have the master that's going to continue to have sort of the stuff that we've been working with. And then we're going to make a branch, and that's going to allow us to experiment. And we could have more than one branch, and we can switch between those branches so that we could make changes to the master branch and make separate changes to some other branch. And then at some point, we're probably going to merge our changes back together if we decide that our experimental branch actually had changes that were worthwhile. So the basic process is we might make a branch, try some things out, we might get rid of that branch if it didn't work out very well, or if it worked out pretty well, we might merge those changes back into the current working branch. So that's the sort of workflow, that's the sort of workflow of branches. So let's finish there. We'll pick up with finishing off this Git stuff and starting on Unit 4 on Friday, and in the interim on Wednesday, Tessa's going to talk about Unit 3, which is basically reading and writing files and information to and from R. Yeah.
And for question 3, I see because you asked me to
Actually, can you hold on 1 second?